Okay, we had finished lesson 7. Lesson 7, there was a lot going on. And then sometimes students think, okay, now you're doing lesson 8 and lesson 7 was already really big. Lesson 8 is actually, there's nothing new in it. So it is just taking the skills that you learned in lesson 7 and it's just sort of perfecting those skills. So there's, I think, 6 class examples that we'll go through and we'll talk about which ones are very similar to test questions, things like that. What I did do is I've uploaded the classroom with the link for the first video. So if you needed to rewatch anything, that link is there. And then as soon as this lesson is done, I will do the same thing. I'll put it up on YouTube, but then I'll just give you the link on the stream. Okay, so let's just, again, go over what we did in lesson 7, and then let's do some practice examples. So this is your final formula with all 4 parameters or all transformations. It's very similar to the one I gave you. The one I gave you, though, is more common to what you'd see on the diploma, which would be y minus k. So they'll have the vertical translation on the left-hand side is equal to your a parameter, and then you have your function. Within your function, you have your b parameter, which is factored out, and then x minus h, 2 brackets. So again, always make sure that that b parameter is factored out. You would get, if you do not factor it out, you're going to get your h parameter wrong. So that is what we did in lesson 7, along with the mapping. So I'm going to quickly write the mapping down because you will not find the mapping anywhere in this workbook because they don't teach the mapping. So how the mapping works is once you have a coordinate, and we'll do some mapping, some more mapping in this lesson as well, is you take your x coordinate and you divide it by b and you add h. This will give you x prime. That's your transformed x coordinate. So that there gives you x prime. In order to get your new image y coordinate or y prime, it's your a value times y plus k. That will give you y prime. As well, something to sort of note, you know that x is related to domain. So the 2 parameters that affect domain are b and h, right? Because the x affects your domain. That means that the a and the k, that would affect range. And then the b and the h are domain. When we discuss transformations, unless they say in this specific order, and on the test it wouldn't do that. On the exam, it would just give you, I'll show you what it would give you on an exam. It would give you something like this, and then you have to discuss the order, and you would always discuss the order in SRT. So SRT is when you're given a final function or a transformed function, and they say describe the transformations, you always want to talk about your stretches first, you want to talk about your reflections second, and you want to talk about your translations last. With mapping, though, like I said in lesson 7, this mapping actually takes care of SRT. And with one of the questions, I'll show you exactly how I would do it, and then I'll show you a different method, how a different teacher would do it. I'll just show you the picture of how they would do it, though. Okay, so let's do this first class example pretty quickly. This one should be nice and easy. The b values factored out. All this question says is if the equation is written in this form here, state the values of a, b, h, and k. So that's all I want you to do. Look here and write down what a, b, h, and k are. So the a parameter is 2. The b parameter is 1/2. I made sure that the b parameter is factored out, and it is. This is going to give you your h parameter, and h is -5. And this is going to give you your k parameter. K is equal to -8. What it says for b, write the transformations associated with the parameters. On a test, they will always use the word describe. Unless they say in this particular order, you always want to do SRT. And what's actually kind of interesting is if you write your parameters as follows, A, B, H, and K, I actually just go from left to right. So I would start with this A parameter, and then I do B, H, and K, because that would follow SRT. So the first thing I'm going to talk about is the A parameter. Remember that A is your vertical stretch. Now, for simplicity, in your notes here and in your homework, I'm okay if you write vertical stretch, stretch factor of 2. On your exam, you must write out the word vertical, and you must write out the word stretch. So you cannot shorthand this. If you shorthanded that on your diploma, you would be losing marks. So I'm going to do the same thing, and I'm going to mark it as you were writing a diploma. So you're going to write fully vertical stretch, and you're also going to write stretch factor, okay? There's only going to be one question, though, in the long answer where you're describing. B, or number 2. This parameter here is a horizontal stretch. So again, if this was an exam question, I'd be writing out horizontal stretch, and then I'd be writing out stretch factor of. The B parameter, the stretch factor is always the reciprocal, so stretch factor of 2. Then there's no reflections, right? So stretches are done. There were no reflections. I go to translations last. It doesn't matter whether you start with the H or the K, just like with the stretches, it doesn't matter. I'm just going to go though from left to right. So I'm going to start with H. That is a horizontal translation. So you would write that completely out on your test. Then you tell me how many units in what direction. So -5 would be 5 units left. The last transformation is this K parameter. So you'd write out vertical translation. What was it? 8 units, and then the direction. 8 units down. And that's how you would describe. So just to sort of, again, on your exam, you would get something like this. The only difference on your exam is the B value will not be factored out. So I think we will be doing question. Yes, there's going to be one in this lesson where the B value is not factored out. And then this is how you would describe it. Okay, we're actually not going to transform this because we'll do a different example where we're transforming. But what I would like you to do now is we are going to do D. D is where we're given now the equation and what is the new equation. So, and this is all the replacement stuff. You have to be good at the replacement notation in order to get this correct. So let's just quickly write above here. Your A parameter is 2. That is going to be a Y replacement. And the replacement is, if I want a 2 in front of this function, it's going to be Y is replaced with 1/2 Y. So take your original equation, Y is equal to X squared, draw your arrow, take out this Y, and put in 1/2 Y. What you would then do is I need to get a 1 here. Essentially, I need to get rid of this 1/2 because it's a fraction. I'm going to multiply this by 2 and this by 2. 2 times 1/2 would cancel. And I am left with Y is equal to 2x squared. That's my A parameter. Okay. Now let's do our B parameter. So our B parameter is 1/2. This is an X replacement. The replacement for B is X is replaced with 1/2 X. So take your equation, Y is equal to 2x squared. And what we're going to do to this equation is I'm going to take this X out and I'm going to put in 1/2 X. Because there's a squared, I need to include a bracket and the square on the outside of my bracket. So what this would become is Y is equal to 2. That X comes out and 1/2 X goes in. From here, if you're able to clean up. So we can clean this up. What we could do is this 2 goes on the X, it could go on the 1, and it could go on the 2. So this becomes Y is equal to 2, because that was my A, times 1/2 squared becomes 1/4, or sorry, 1/4. x squared. Okay. Now from here, I could multiply these two numbers together. 2 times a quarter is 2/4, and that's 1/2 x squared. So I could get rid of these brackets, and I could write it as y is equal to 1/2 x squared. So this is why you need to be really good at replacement, because we started with an a value of 2, and now sort of look where my equation is at, right? So if you're not good at this replacement, you would have never gotten to this step, because people would be like, well, where's that 2? Well, the 2 is right here, and here's the b value, right? And then they got multiplied together to become 1/2 x squared. Okay, let's do the next one. This is our h. H is equal to -5. That's my h value, right? But what I want is it needs to look like this. Remember, if h is -5, the replacement is an x replacement. And in order to get a -5, x is replaced with x plus 5. So this is my new equation. So I'm actually just going to write that current equation, 1/2 x squared. And what the replacement is, this comes out and x plus 5 goes in. So put in an x plus 5 in a bracket with a square on the outside of the bracket. That would be y is equal to 1/2. And the replacement, x is replaced with x plus 5. So now there's my h parameter in there. My a parameter is in and my b parameter is in. This is where I'm at with my equation. So then you say, okay, am I done, or do they want me to do something else? The last thing was this k parameter. K is equal to -8. The replacement for k, that's a y replacement. Y is replaced with y plus 8. If I want a -8 go out here, I replace this guy with a y plus 8. So I'm going to write my equation where I was. So I'll just rewrite this. Y is equal to 1/2 x plus 5 close bracket squared. I'm going to take this out and I'm going to put in a y plus 8. So I'm sort of doing all the steps as if this was an exam question. Equals. And then what did I have? I had 1/2 x plus 5 close bracket squared. Okay. Remember that this k parameter, it goes outside of your function. So now this is considered my function, and it's going to go on the outside of my function. So to get rid of the 8, you're going to subtract 8, and you're going to subtract 8. And this is your final answer. Y is equal to 1/2 x plus 5, close bracket squared, minus 8. So the previous example that we just did, it was a describe question. This would be like a 2 or 3 part question. The first one is always describing based on transformations that I've given you. And then the second part, it'll always be, I give you an equation, and using replacement notation, after all of those transformations, what would your final transformed equation be? So the original equation was x squared. After it undergoes all those transformations, this is what it becomes. Okay. And again, I think there's going to be 1 or 2 more of this type of question. Okay, let's do one with mapping. So it says the graph of y is equal to f of x is shown. So this is the graph of y is equal to f of x. Sketch the graph of y is equal to -2f of x minus 3 plus 1. So I need you to write all of your parameters. What's this parameter, what's that guy, and what's that guy. I look, there's a 1 in front of my x, so I don't have to factor out, there's no b value basically. This is your a parameter. A is -2. This is your h parameter. H is 3. This is your k parameter. K is 1. We are going to map x, y goes to. It is x over b plus h, a times y plus k. From here, xy, what it goes to, x over b. If there's no b, b is 1, right? X over 1 is just x. And then plus h, so plus 3. So I'm going to take all of my x coordinates and I'm going to add 3. My y coordinates, I'm going to multiply them by -2. So -2 times my y coordinates, and then I'm going to add 1. So let's write A, B, C, D, E. So these are sort of nice points that we could pick. And then let's do our mapping and get A prime, B prime, C prime, D prime, and E prime. Okay. And then again, I'm going to show you how the book would do it and how a couple other teachers would do this. So this is A. It is at -3 and -2. B is right here, -1, 0. D is this guy. X is 0, Y is 4. D, X is 2, Y is 0. And E, X is 3, Y is 5. Okay, you could do it in your head or you could write it out. I am okay with whichever you do. But A prime would be -3 plus 3 is 0. That's going to be 4 plus 1. This would be 0, 5. So you could just check your answers against mine. B prime, I would get -1 plus 3 is 2 and 1 here. C prime, 3, comma, so 4 times -2 is -8. -8 plus 1 is -7. D prime would be 5 and 1. And E prime would be 3 plus 3 is 6. -10 plus 1 is -9. So once you have all 5 of your transformed points, let's plot A prime, B prime, D, D, and E. And then we're going to connect those dots. So it looks like a mess, but 0, 5 is right there. So that's A prime. And that is going to be connected to B, which is at 2, 1. So it's like I'm going to draw a straight line there because that would be these two, right? So A prime to B prime. And then C prime is 3, -7, which is down here. D prime is 5, 1. So like this parabola, which was like B, C, and D, is now B, C, and D. So I'm going to try to draw this as a parabola. And then, so that's D prime. And then this point was E, and E was at 6, -9. So 6, 5, right here. Okay. So A to B was a straight line. So I would make sure that my A prime to B prime is going to be a straight line. And then it's going to go B to C to D. And this was like a parabola. So I'm going to try to make this curved if I can. I probably won't be able to. Okay, not bad. And it's going to go up and come down to there. And that would be E prime. If I was like writing this as a test though, I'd be erasing this and just making it straighter here. And I'd be making sure that that's touching. But yeah, so this is how I teach this. I like teaching this mapping, okay? What I had mentioned is some teachers, so like Mrs. Stevenson, she would get her students to first take the original graph and stretch it. They would have to draw that. Then she would make them reflect it and then translate. So I'll actually show you what like an alternate way to do this would be. I'm not going to actually do it because I don't like this method, but look at this. So when her students hand in their exams, this is what they hand in, because first she gets them to do the stretch, then she gets them to do the reflection, then she gets the translations done. So she will always see on her tests 4 to 5 different graphs. My students, when they hand them in, I mark one graph because my students will always map, right? So it's, if you didn't want to map, like if you're like, I can't figure out this mapping, then you would be doing stretches, then reflections, then translations. But the majority of tests that I get handed in, probably 95% of my students will always just map and then you're done. Okay, that is class example number 2. Let's look at class example number 3. Consider the function f of x. So they're not giving me an equation. They want replacement notation, so they want what the replacements are. And then they want the equation in this form here after it undergoes all of this. So let's do what it's asking. Horizontal stretch by a factor of a quarter. I know that that's my B parameter, right? Horizontal stretch. So if the stretch factor is equal to a quarter, the B parameter is the reciprocal of a quarter, which is 4. The reason why I want to write that is because I know that this B value has to be 4. That helps me see what the replacement is, because I know that this X is going to come out and it has to become 4X. So the replacement is X is replaced with 4X. So they're not giving me a formula. I find it easier when they don't give you a formula. You'll always get a formula though on the diploma or on your tests. So that is the original. Take this out and plug in a 4X. So F of 4X. There. You would say, if I gave you this and I said, well, what is this? You'd say that's B. B is 4. B is a horizontal stretch. The stretch factor is the reciprocal, right? So this all sort of makes sense. The next thing it says, okay, there's only one more transformation. It's a translation. Vertical translation 5 units down. I know that that's a K value, right? K is equal to -5. I know that this has to be -5 at the end. What is that replacement? If it's a K replacement, it's a Y replacement, and Y is replaced with Y plus 5. So what we are going to do is, I'm actually just going to do this in, I'm going to continue this because it's not much room. I'm going to take this out and I'm going to put in a Y plus 5 is equal to F of 4X. I am pretty much done, but they want it in this form here, which is telling me they want me to isolate the Y. So I got to get rid of that plus 5 by subtracting 5 to both sides. And my final answer would be F of 4X minus 5. That would be your answer using replacement notation. Let's do the exact same thing for B. They're just going to give me different things that are happening. So this vertical stretch factor of 3/5. So you have to say to yourself, what parameter is that, right? And then what's the replacement? So just to sort of visualize this, we know that this is y is equal to f of x, right? That's what we're going to be given. A vertical stretch is an a value, and it's going to be the same as the stretch factor. So if the stretch factor is 3/5, that means that the a value is 3/5. That means I need to get a 3/5 in front of my function. How I do that, though, is the y will lie. So y is replaced with, instead of 3/5 y, it's going to be 5/3 y. So watch how this will work. The original equation is this. Y is equal to f of x. Draw your arrow. I need to get a 3/5 over here. So I'm going to take this y out, and I'm going to put in 5/3y is equal to f of x. In order to get this to become a 1, right, I want the y by itself, I'm going to multiply by the reciprocal. So I'm going to multiply this by 3/5, and I'm going to multiply this side by 3/5. Because 3/5 times 5/3, that will just cancel. That becomes 1. So now here's my new equation. Y is equal to 3/5 f of x. Okay, then it says a reflection in the y-axis. So let's figure out what this is. That's my y-axis. It's going from here to here. That is a horizontal reflection. I don't really care about horizontal reflection because it's not asking that. I just need to be able to look at this and say, what's the replacement? Is y going to negative y or x going to negative x? And the answer is x is going to negative x. So within this equation, I'm going to take this x out and I'm going to put in a negative x. So let's see what we would get. Y is equal to 3/5 f of, take out that x and put in a negative x. That is basically your b value right now. B is -1, and if b is negative, that's going to be a horizontal reflection. Okay, from here, there's one more thing that's happening. They want me to do a horizontal translation, so I know that's going to be an h parameter, 2 units left. H is going to be -2, right? If they want to go 2 units left, it's going to be -2. Now, to get a -2, it's an x replacement, and it's always going to be x is replaced with x plus 2 for this one. So because I'm running a bit out of room, I'm going to rewrite this so that we could clearly see what's happening. I'm just going to rewrite this. Y is equal to 3/5 f of negative x. So what's happening is this x is coming out and an x plus 2 is going in its spot. This I'm going to put in a bracket. So watch why I would put in a bracket. Y is equal to 3/5 f of, I'm going to put that negative, and then I'm going to take this x out, and I'm going to put in an x plus 2. Okay, so I would get this. And the reason why I would keep it like this is because if I distribute in this -1, my b value technically has not been factored out, right? You always want to make sure in front of your x, you guys, you always want to make sure there's a 1 there, right? So if you distribute in that negative, you'd have negative x minus 2. And we always want to have x and then plus or minus something. There's your a value. There's your horizontal reflection. Here's your horizontal translation. The h parameter here would be -2, and it matches up. So that is my final answer. Okay, let's look at class example 4. A function g of x is transformed into a new function p of x. So my original function they're calling g of x is going to undergo some transformations. They're going to ask for the equation of the new function. I have to call it p of x though. To form the new function p of x, g of x is stretched vertically about the x-axis, so just vertical stretch by a factor of 0.25. So I don't know why they gave this as a decimal, like you would never see this as a decimal, but 0.25 is 1 over 4. So first thing I'm going to do is I'm going to underline this vertical. I know that vertical stretch is an a value, right? The vertical stretch is an a value. If the stretch factor is equal to 1/4, right? The stretch factor is 1/4, the a value is 1/4. So I always find a is nice and easy. The replacement though, I need a 1/4 in front of this function. The function is x cubed. How I do that though is right now I'm going to call this y, right? We'll change it at the end, but the replacement for this, so let's just write actually this equation. So y is equal to x cubed. I need a 1/4 here. How I do that is y comes out and the y will lie. I'm going to replace it with 4y. So for this, I'm going to take out this y and I'm going to plop in a 4y is equal to x cubed. Now I need to get rid of that 4 by dividing that side by 4 and this side by 4. And there's an invisible 1 there. Now I have y is equal to a 1/4 x cubed. That's my a value right now. It is in front of my function. Okay, reflected in the y-axis. That's a reflection in the y-axis. That is a horizontal reflection. Again, doesn't matter that it's horizontal. The only reason why I draw this picture is because now I know the replacement. And if it's a y-axis replacement, x is replaced with negative x. Okay, so in this equation here, I'm going to take out this x. So I like boxing it in when it's like an x replacement. That's coming out, a negative x is going in. The cubed is on the outside of a bracket. So my new equation is going to be y is equal to 1/4. Oops, I'm going to do that in blue. Black. Okay, I'm going to take that x out and I'm going to put in negative x. Remember I always said if you could clean up, clean up. So how we could clean this up nicely, and only do this if it works nicely, that 3 can go onto this x. This is a -1. If you cube a -1, it stays as -1, right? So what this would become is y is equal to, it's a 1/4 times -1, which is -1/4, and then x cubed. Again, this is really a -1. -1 cubed is -1. -1 times 1/4 is -1/4. So now here I am. Okay, I think there's one more thing that they're going to do. And translated 3 units to the right. That is an h parameter. If it's going to the right, h is 3. The replacement is an x replacement. If I want to get 3 though, it's remember x minus 3. So this is coming out and x minus 3 is going in. Whenever I do like an x replacement like that, this is going in a bracket. So that new equation is going to be -1/4. The cube is on the outside. That x comes out and x minus 3 goes in. I am done. I am not going to box this in though. And the reason is you would actually lose a full mark if you did this. I cannot call this y. If they specify, like this would be a 5-mark question. If they specify, or sorry, this would be a 4-mark question. If they specify that the new function is p of x, you must write that. So p of x is equal to -1/4 x minus 3, close bracket, cubed. That is my final transform function. The original was g of x, like this was the original, you don't have to write this, but g of x was equal to x cubed. After everything they told me, I get this final answer here. So what I'd be checking for, if this was like an exam question, I'd be checking that all of this is correct, right? If this was a 4-mark question, if one of these were wrong, you'd be losing a mark. I'd be checking that you start with your original equation and then you have your arrows and you're doing your replacements properly. I'd be checking that you're not dropping equal signs. And then I'd be checking something like this, that if there's something easily that you could distribute, you would do it. What we wouldn't do is this. I'd never ask you to clean up this because you'd be taking this binomial and you'd be multiplying it by itself 3 times, expanding it. You'll never be asked to do that, right? But something like this, you could easily do to help you clean everything up. Okay, so that is class example 4. Class example 5. What we will do is, I'm only going to do a couple things with class example 5. we're not going to actually take the time to fully draw the picture. We'll just set it up and then you could draw the picture for homework. The reason why I like this one though, this one here, is because if you look at this, the B has not been factored out. So this is very close to what you would see on a diploma, right? So what you need in order to have the B value factored out, this basically needs to be in a bracket because you need to have a 1 in front of your X. This has a 1/2. So in order to factor out the B, I'm going to divide that by 1/2, and I'm going to divide this by 1/2. So the equation is actually y is equal to F, open bracket, factor out that B value. That will cancel, and there's your X with a 1 in front of it, plus 3 divided by 1/2, right? 3 divided by 1/2 is the same thing as 3 times the reciprocal of 1/2, which would be 6. And then outside the bracket is a -8. So again, you guys, you would get this entire question wrong if you didn't factor it out. The reason is this: if you don't factor it out, you're going to tell me that your H parameter is -3. It is not -3. It is -6, right? So just always, like, when it's just saying, is that B value factored out? From here, let's just write what the parameters were. So A, there is no A value. There's a 1 here. I'm not going to bother writing that. This is my B parameter. B is 1/2. This is my H parameter. H is -6. This is my K parameter. K is equal to -8. The only thing I want to set up with you is what would the mapping be? Because if I gave you this on an exam, you would map it. So the mapping would be X comma Y goes to X over B plus H, A times Y plus K. So I always write down what the full mapping is. And then from here, I'm going to put in my parameters. X, Y goes to, now, X over B. So I don't want you to write X over 1/2 because that looks really messy. Remember that if B is 1/2, the stretch factor is 2. So you could divide by 1/2, which is the same thing as multiplying your X by 2. So that would actually be 2X plus your H parameter. H is -6. A times Y, there is no A, so it's just going to be Y plus K, so plus -8. That's your mapping. But then at the end of the day, I'd fix this and I'd write negative here and negative here, right? There's no sense in having that. A plus a negative is just going to be a negative. And then how you would do this, so I recommend doing this for homework, but this would be A, call that B, C, D, and E. Then you're going to map A prime, B prime, C prime, D prime, E prime. It's nice and simple when it's straight lines. Then you're just going to connect A prime to B prime to C prime to D prime. Okay. So I will let you do that after. And the solution, like when you get to it, it's going to look like a giant mess because they do it all. So this is how you'd have to do it if you weren't mapping, but this is going to be your final answer. So it's going to look something like this at the end. So if like this matches up and that point matches up, that point matches up, then you guys are good. It would be extending past this slightly. Okay, let's do one more question, and that's the last class example, which is class example number 6. I really like number 6 as well. And basically, I'm going to like any question where the b parameter has not been factored, because if you look at this, there's a 3 in front of the x. That's the b value. I need a 1 in front of the x. So let's rewrite this entire thing, and let's take out this here. Let's divide this by 3 and this by 3. G of x is equal to -2 square root. The 3 goes in front of a bracket, and you'd be left with x minus 12 divided by 3 is 4. And then this 5 is on the outside of the bracket. So what this question is saying is it's saying this is what you started with. You started with f of x. You did a whole bunch of stuff. Oh, I didn't write what f of x is. F of x is equal to the square root of x. So look at what they did to the square root of x. They put an a in front of it. They put a reflection, right? If I put a -2 in front of here, there's a stretch and a reflection. Inside the function is my b and my h. Outside of the function is my k. So before I even look at this question, let's write all of these parameters. That is your a. A is equal to -2. Vertical stretch, stretch factor of 2. Because this is negative, it's going to be a vertical reflection as well. This is your b. B is equal to 3. Horizontal stretch, stretch factor, 1/3. This is your h. H is equal to 4. Horizontal translation, because h is 4, it's going to the right 4 units. This guy is your k parameter. K is equal to 5. Vertical translation, 5 units up. So let's write everything down and see if we get the answer. The function f of x has been transformed to the function g of x by stretching it horizontally. So as soon as they talk about horizontally, they're going to talk about the b parameter by a factor of. So I just look up here. Horizontal is always my b. If b is 3, the stretch factor is 1/3. So horizontal, they're talking about b. Here they're saying a factor of 1/3 would be your answer. Then next, I'm going to go here, stretching vertically. They're talking about the a parameter, right? So this is where students will mess up on a test. Some students will say by a factor of -2, and you would actually lose a mark or lose half a mark for that. The reason is, remember when you talk about stretch factor, ignore the negative. It's always going to be the absolute value of either the a or the b. And the stretch factor is 2. That negative indicates a vertical reflection. So reflecting in a vertical reflection, you're cutting the x-axis. Translating blank units up. So I look, 5 is the answer. And blank units horizontally. Okay, that's going to be my h. H is 4. 4 units horizontally to it's either going to be left or right. I look at the h. If h is positive, it goes to the right. And that is how you would do this question, factoring out the b. So let me see. I just want to see if this matches up with what I had assigned. Just one quick second. I'm just looking at your note package where I wrote down homework, and I just want to see if it matches. So 1 to 3, 4, C, D, E, 5, 6, A, 8, 10, and 11. Yep, so it matches. So this is going to be your homework that you're going to do for lesson 8. If you're going to understand anything, it's this lesson, right? Because this is putting everything together. So make sure you have a really good understanding of all of these questions. And then you probably have already written down some lesson 7, but the podcasts that you want to watch tonight are 8A, 8B, and 8C. There's going to be a few podcasts tomorrow. So just give me a minute, you guys, and I'm going to stop recording this.